Let's do an example of a number of ways that we can generate passwords. So we'll make this nice and simple with only allowing capital letters A through Z, right? So in other words, we've only got 26 possible characters, and we're going to go through and figure out how many passwords can be made. One, if we're allowed to repeat letters, right? Like, should A count as a reasonable password? Or if we don't allow repeats and we've got to have different letters for each thing. So we've got an 8-character password, right? 1, 2, 3, 4, 5, 6, 7, 8. All right. And for that first letter of the password, I can have any one of 26 possibilities. And for this first question, it's what if repeats are allowed? Okay, well, in that case, I can choose any one of 26 again, any one of 26, any one of 26, and so on. So what is this really going to be? 26 to the 8th power, right? Because I've got 8 slots, right? 8 characters that I'm going to have for this password, and I've got 26 choices for each one of those. So this one is just a direct application of that basic counting rule that we have. Now let's say, what if we cannot repeat any of those letters? In other words, for this first one, I've got 26 choices. And then for that second character of the password, I've only got 25 choices left because I've just used one of those letters for my first letter. So now I've got 25, and then 24, and hopefully you're seeing the pattern here so I don't have to write out all 8 of these, right? This is actually how we start that permutation, right? Because the reason why this isn't just a direct factorial is because it's not 26 characters long. I'm not entering in all 26 letters. I'm only using 8 of those letters in the password. So that's why it's not directly a factorial. Instead, I'm choosing out of 26 things, or permuting, let me be careful with that. I'm permuting 26 things, and I only want to pick 8 of them. And in this permutation, there will be, again, 8 characters chosen out of 26. And this is where this permutation assumes that the order in which we pick those 8 things matters, right? That the A, B, C, D, E, F, G, H is a different password than A, C, B, D, E, F, G, H, right? It's got the same stuff in it. We've picked the same 8 letters, but the ranking or ordering actually matters here. The order in which I've listed those things actually matters. We need to treat those as different things and make sure that they're being counted as separate passwords. So that's why I know it's a permutation, again, with 26 choices, and I'm choosing 8 of them.